This is the first video on Chapter 40, the Riemann integral. There are going to be a lot of videos on the Riemann integral. There are a lot of components that go into defining the Riemann integral. And so I'm going to start with just some very basic building blocks, and there's really nothing about the integral itself in this particular video, but you need to understand the material from this video to actually understand what's going on with the integral. And so basically what I'm going to do in this video is explain what a partition is. And so we start with an interval, left endpoint A, right endpoint B, and we chop the interval into pieces. And so that's why we call this a partition. And so we index the x sub 0 with A. X sub 0 in your left endpoint is the same thing, and x sub n in the right endpoint. So x sub n is equal to b. So your partition is a set of points, a equal to x sub 0, x1, x2, up through xn, which is equal to b. When you get into other math classes, a partition is going to be called something else. And so the word partition gets used in a few different ways in mathematics, but in calculus this is how we use partition. We just refer to it as these points. And you'll notice the x1 is strictly less than x2, the x2 is strictly less than x3, the xi is strictly less than x sub I plus 1. This is part of the definition of partition. And so the partition is a set of these points. Now, we look at the distance here from one point to the next, and we call that delta sub I. So delta sub I is x sub I minus x sub I minus 1. We define that for all I between 1 and n. So for example, delta sub 1 is the distance between x sub 1 and x sub 0. So this is x1 minus x0, that's delta 1. Delta 2 is this distance, x sub 2 minus x sub 1. And the way I've drawn this partition, these delta i's are different. They're allowed to be, they don't have to be. So you can make a partition where all the delta i's are the same. I did not do that for this example because I want to illustrate the fact that it doesn't have to be that way. This is your delta I. And then we call the norm of the partition, or the length of the partition, is the max of the delta i's. So you have a finite set here. So you have a finite number of these subintervals, and you're looking at their lengths. And when you have a finite number, you have a largest one. Now, you might have two the same size. You might have two that are both the largest distance, and that's okay. And again, these distances can all be the same, in which case this number would simply be that distance. With the way I've drawn the picture, the distances are different, so you take the largest one. Not necessarily a unique, but it's the largest one. That is the length of your partition. It's the largest delta I. And so this is the notation and terminology that we're going to use in this chapter.